Good afternoon, everyone. We have a really interesting discussion ahead. My name is James Fallows. I'm a writer for The Atlantic. I'm here briefly to introduce our guest, Hal Harvey, who has been one of the leading serial entrepreneurs and innovators in the field of energy and climate for several decades. His current firm is Energy Innovation. Before that, he was a founder and director of Climate Works and the Energy Foundation. He's well connected in China and the United States, and the innovative ideas on what to do about the climate problems we're all familiar with are what he's going to discuss. So please join me now in welcoming Hal Harvey.
Thank you, Jim. This is entitled Fear and Hope, and like Marines in boot camp, I intend to destroy you and then bring you back newly made. So there's a lot to fear in climate change, and I'm going to talk about three aspects of it that are not commonly understood. The first has to do with weather. We think of climate change as increasing the global average temperature of 2 degrees C. That doesn't sound like much, and that's because it's not much. But that's not what matters. What matters is extreme, so I'm going to show you something interesting about that. Then I want to talk about how natural systems react to the man-made perturbations that we're causing. Then a little insight into carbon math, which is truly frightening. And then after that, I'm going to talk about some spectacular advances in technology that can bring this home in a reasonable fashion. I'm an engineer by training, and so I have to start with a normal distribution curve. Everybody's seen a lot of these. This one happens to be a representation of July temperatures across the United States. And because it's a normal distribution curve, you get about a third of your summers are cooler than average, a third are average, and a third are hotter than average. Note down here in the extremes, there's very little stuff going on. And the extremes are what you care about. The extreme is the 100-year flood. It's the Dust Bowl drought. It's what's happened to Australia recently. So this is from NASA. Watch what's happening in the real world. So you can see the actual temperatures very much fit this model for years. And then look what happened starting around the late 70s and the early 80s. We moved the average over just a little bit. Here's where we are today. You can see we used to have 1/3 cooler than average summers. We're now down to 1/12. 1 out of 12 summers is cooler than average. 1 out of 6 is average. 4 out of 6 are hotter than average. And 1 out of 12 are extreme. Never been seen before. Yesterday in Death Valley, it was 129 degrees, you probably saw. Phoenix, 120. Las Vegas, 117. Those are extreme temperatures. Let me give you some more examples. We had the biggest drought last year since the Dust Bowl. This is in Illinois. It was worse in Texas. It's worse today in New Mexico. Another kind of extreme is an extreme flood, an extreme weather event. 65 out of 75 of Thailand's counties were underwater. Bangladesh has had more than half the country underwater. Australia recently had flooding the size of France. Another kind of extreme, heat. In Australia, they burned 1 million acres earlier this year through fires. The extremes become the norm. This is what's happening to our weather systems. We have to get used to it in a way. Australia had a day when the average temperature across the entire continent was 106 degrees. And in the hottest place, it was 122. That's not bearable. People remember Superstorm Sandy, a 1,000-kilometer wide storm, caused $65 billion worth of damage. So this is what's happening to weather systems. It's not the average that we care about, it's the extremes. Now, you may have noticed that even as we were creating a lot of hot extremes, we were eliminating cold extremes. Cold extremes have an important ecological purpose, and around here they kill pine beetles. When you quit killing pine beetles prosper, and you kill pine trees. And there are now millions of acres of dead pine trees around here. So if you want to know what's happening with climate change, go outside. So that's the first bad news. It's the extremes become the norm. If you're interested in this, we have a short paper called The Extremes Become the Norm on our website. You can dig into it. Let me turn now to the next really scary thing. When human beings unleash changes, geophysical changes in the atmosphere, nature follows with its own medicine. And it's sometimes more extreme than that which we ourselves do. This is the Arctic. These are real images. The sunshine bounces off the snow. So you get a lot of sunshine coming in, hitting that ice, and bouncing off. But look what happens to the snow, or the ice, I should say, over time. It disappears. And when the sun hits the dark ocean, it doesn't bounce anymore. It absorbs. So we started this by melting the ice, and nature's accelerating it. It's a runaway cycle. There are several of these in nature. This is the one that's the scariest to me. There are millions of square kilometers of frozen tundra across the north of Russia, Canada, and Alaska. Embedded in that is frozen CO2 and massive amounts of frozen methane. Methane is an incredibly powerful greenhouse gas, 25 times as powerful per kilogram as CO2. If you melt the tundra, you release the methane. And there's no earthly way for us to stop that. Now, are we melting the tundra? We're starting to. The Arctic is warming at twice the rate of the rest of the world. It was 90 degrees in Alaska earlier this month. So the extremes become the norm, and systems go into runaway. Here's some other runaways. The warmer the air, the more its water vapor capacity. That makes clouds. Clouds are like blankets to the earth. They accelerate the warming. So each of these things causes more of the same. On the other side of it, we've had an incredible escape valve. Almost half of all the carbon dioxide that humanity has released so far has been absorbed by the ocean. But when you warm the ocean, its ability to absorb carbon dioxide decreases. So our safety valve is shutting off even as our emissions are accelerating. Okay, everybody feeling depressed? I got one more. People have always talked about a threshold we should not exceed of 450 parts per million concentration of carbon dioxide in the atmosphere. We're at 400 today, by the way. We just passed that threshold about 3 weeks ago. I'm going to argue that actually higher numbers, though they would seem instinctively to be easier to attain, are harder to attain. So we better stop now. And I'm going to show you why. This is simple math, but not widely dealt with. What we do as society by driving cars, by building buildings, by flying around in jet planes, is we emit carbon. And this is business as usual carbon emissions. Today, we're around here, 50 billion tons of CO2 emissions per year. And that's where we're headed. When you emit carbon into the atmosphere, it stays up there for a very long time, up to 1,000 years or more. And so if your emissions keep going up, your concentrations keep going up. Let me say again, this is what we do. This is what's done to us. This is the insulation blanket we're putting over the Earth, getting thicker and thicker. So let's say we get smart, we get clever, we get aggressive, we develop some willpower, and we reverse that trend, and we start pushing carbon dioxide down from its peak to close to zero over about a 50-year period. And I'm going to argue that's entirely possible. Look what happens to concentrations. They stay level. It's like putting money in a bank. You quit putting money in the bank, the money that you have in there doesn't disappear, it stays there, right? So if we go to zero carbon emissions, we stay at 450 ppm. Look what happens if you wait a little while. Let's say we wait another 25 years, and then we go to zero. That puts us in the 650 world here. Here's the really interesting thing, and this is why I say the 650 world, besides being much worse from a climatological perspective, is actually harder. The economic change that we have to encounter is the difference between 60 billion tons of emissions a year and roughly zero. If we wait, it's 100 billion tons down to zero. The longer you wait, the harder it is to achieve any stable number, even a totally dangerous, ridiculously bad stable number. In other words, if we wait, I predict we go into absolute runaway, unrecoverable mode, into a time we've never seen before. By the way, today at 400 ppm hasn't been seen in 3 million years, since long before humanity. Last time it was 400 ppm in the world, it was 75, the oceans were 75 feet higher. So this is real. Okay, that's carbon math. What I want to turn now to is from fear to hope. But there's an intermission, which is called natural gas. Is natural gas good or bad? Both. It all depends. If you look at one thing, natural gas looks pretty good. If you displace coal with natural gas, then you're going to emit half as much CO2 at the power plant. But if you look at the full cycle of natural gas, you've got a few other problems. This is what I started with. This is the amount of CO2 from coal, and that's from natural gas. It would be a good substitution if you want to save the climate. But if you have very small methane leaks, remember methane is an incredibly powerful greenhouse gas, then some of that benefit goes away. If you have large methane leaks, gas is far worse than coal. So a reasonable question is how much methane is leaking. And the answer is no one knows. We don't keep track. And we've seen studies that have this high number, and we've seen them that have this low number. So we need to find this out. Let me say one other thing about clean natural gas. This is what it looks like when you're getting it out. It might be clean in your stove. It's not as clean in Pinedale, Wyoming, which is where this is. It's an incredibly land-intensive source. So I would say natural gas can be a useful bridge if it's managed very well. It can be an extension of a very bad addiction if it's managed badly. All right, now let's go to the real hope here. I saw a headline in the newspaper a couple days ago that said Nevada rejects coal, turns to renewable energy. And last month, the Nevada legislature outlawed coal, is planning to shut down their biggest coal plants, and they promoted renewable energy significantly. There are now 30 states in the United States that have requirements that the utilities deliver a certain fraction of their energy from renewable energy sources. The first one was in Iowa. The second one was signed by Governor George W. Bush in Texas. These things have been an incredible success, and they're just starting to show off. The Texas one has been expanded twice. They've built these unbelievable windmills here. Each of these sweep an area of 30,000 square feet, much bigger than a football field. These things are enormous. Other states have done this. California has already signed contracts to provide a third of its electricity from renewable energy by 2020. So you can begin to see the glimmer of hope in here. If California, pretty big economy, can go to a third, has already signed all the contracts, it's not so bad. Other countries are ahead of us. Denmark recently had a day when it was 100% renewable energy. Holy grail time, right? Their average is 41%. Now, Denmark's not a big country, but that's pretty interesting. And one of the things they've learned is how to manage the variability of renewable energy sources. So it's happening. When you build markets like this, when you stick with it year after year, you get this spectacular phenomenon. And this is the other reason for hope. If you drive prices down, you get dramatic increases in installations. Solar energy prices have dropped 80% in the last 4 years. Fathom that. We are passing the Holy Grail with this. Wind has dropped by close to a third. And the consequence of this is installations are skyrocketing. There are now several US states that get more than 20% of their electricity from renewable sources. There are provinces in China that do this. And look at what could happen in the United States. This is our current electricity mix in the United States. It's dominated by nuclear, coal, and natural gas. And down at the bottom is biomass, geothermal, hydro, and wind. Solar is too small to even show up because it's just getting going. There was a study done by the National Renewable Energy Laboratory, an amazing place, in coordination with MIT. This is just over the hill near Boulder. And they said, could you get to 80% renewables in the US by 2050? 80% renewables by 2050. They developed a model which is an hour-by-hour simulation of the entire US electricity system from here to 2050, and they added renewable energy bit by bit. And they found the following, that you can get there, and additional cost is relatively small. There's a lot of interesting lessons in this. It's a big story, and we can go into those more in conversation. But the bottom line is you can do it. And if you don't believe it, you should go to Europe, where they did a very similar study, sponsored incidentally by 12 of the largest utilities in Germany and the European Climate Foundation. And they said we can go from these relatively low numbers to much higher numbers. And today, in 2012, Germany's a quarter renewable energy. Germany's a real country. They have a real economy. They're getting a quarter of their energy from renewables, up from about 6% in a decade. So if they can go that far in a decade, and by the way, they're totally on track to hit these targets. It's not easy, it's not simple, but it's clearly possible. So I'm going to close with 3 slides. How do you win? You have to do 3 things. First, you have to manage fossil fuels. There are far more carbon in the earth ready to be liberated into our atmosphere than we can possibly tolerate. Many, many times as much carbon underground than the atmosphere can handle. And so if you do not put a lid on it, you lose. We lose very badly. So you have to phase out coal. Coal is, I used to say, it's perfect carbon sequestration. It's already in the ground. Leave it there. Natural gas, you have to get it right. You have to stop methane leaks. You shouldn't destroy everything. And there's a few other things like water quality you want to pay attention to. This, by the way, is the Rhone Plateau, a formerly very beautiful part of Colorado. The second thing you have to do is get very serious about energy efficiency. In every sector of the US economy, you can cut energy use by 1/3 to 70%. It's cheap, the payback's incredibly fast. Many of you saw the Nest presentation the other day, these amazing little thermostats. 15%, 20% just by changing your thermostat. Same with your lighting. And finally, we're going to have some very serious conversations with the electric utilities and emphatically with the public utilities commissions that set the terms under which they operate so that they divest from coal, they invest in renewable energy, and let them make money doing it. If the rules for the public utilities commissions are set right, this transition is a breeze. And if they're not, it's an awful struggle. So let me conclude with one thought. And the thought is simply this. If you look around the people next to you here at the Paulson Institute Ideas Festival, and the people you encounter over the next few days, you'll find an incredibly sophisticated, capable, networked, and influential group of people. These are the people who set the ideas that drive the country. Everyone in this place serves on boards of directors of nonprofits, runs corporations, has senior government positions, works with the media. And so I'm calling on you to make this agenda real. If we do not turn this around in the next decade or so, it's inescapably bad. We've been given a gift of technology where we can turn it around. And the difference is very specifically in the policies enacted that govern our energy delivery systems. We need to get those policies right. It's not that complicated. It's emphatically an idea whose time has come. So I'm going to put this all on you to help us all get this done. Thank you.